Hi students, in this session we are going to discuss about UJT and UJT relaxation oscillator. So in the first class itself we know what is PJT and UJT. What is UJT? UJT is a uni-junction transistor. UJT is uni-junction. That is uni-junction transistor. It means that it has only one junction. Then application of UJT is UJT relaxation oscillator. So this is the first I will explain what is the construction, how we construct the UJT oscillator. This is regarding construction. This is the symbol. So for constructing a UJT, unijunction transistor, we took one N-type silicon bar. This yellow color is a N-type silicon bar. This silicon bar is a lightly doped one. Okay, the silicon bar is lightly doped one. Then in the silicon bar, we have to add two terminal, that is base 1 and base 2. That is B1 and B2. We are taking N-type silicon bar. It is a lightly doped one. Remember that it is a lightly doped one. Okay. Then a P-type material is diffused in the near the base 2. This P-type, this region is heavily doped. This is heavily doped. Okay. So because of this region, that is, this is lightly doped, no, there is a high resistance between B1 and terminal B1 and B2. So a unijunction transistor is constructed using N-type bar. In this bar, a P-type material is diffused to construct NPN UJT. Okay, this is lightly doped, this is heavily doped. This is a 3-terminal device. What are the terminals? Emitter, base 1, base 2. And it is a doubly based term, that is component. Double based component. How many bases are there? 2 bases are there. That's why this is called a double based element. Okay. Then why this symbol, a bending arrow in a emitter? Because there is a flow of current from emitter to base. That's why this bending arrow. Actually, in a FET, the construction we are just draw like this. Here there is a bending. This bending represents that there is a flow of current from emitter to base. This is about construction and symbol. Okay. Then equivalent circuit of unijunction transistor. It has, why it is called unijunction? Only one PN junction it has, PN. In a N-type material, one diffuse P-type material, no. Whereas we are having only one PN junction. That's why this is called a PN junction. Okay. So when you draw the equivalent circuit, for that PN junction is mentioned by a diode. I already told that a N-type bar is slightly doped. Between that high resistance is there, no. That's why we are mentioning RB1 and RB2. Why this arrow in this resistor? It means that it is a variable resistance. Depending upon the application of base voltage, this resistance value, that is this resistance value will be varied. Once again repeating how we draw the equivalent circuit. The construction consists of one PN junction. That PN junction is represented by diode. It is that N-type bar is lightly doped. There is a heavy resistance between terminal B1 and B2. Okay, that resistance we are representing RB1, RB2. In this RB1, we are mentioning one arrow. What is the meaning of this arrow? The meaning of this arrow is this is a variable resistance. Why it is variable resistance? Depending upon the application of base voltage VBB, this resistance value will be changed. That's why this is a variable resistance. This is about equivalent circuit. Okay, now we will see the working. So in the working, we divide the working in two conditions. In case one, we won't apply any voltage in the emitter side. There is no voltage. It means that it is connected with ground. It means that it is connected with ground. This is positive, negative. So it is connected with ground. So we are applying a positive voltage between the two base terminals. That is VBB. In this base terminals, application of voltage between two base terminals. Because of that base voltage, there is a high voltage drop between this terminal here only, between this P region and B1 base. There is a high voltage drop. That voltage drop is called V1. Okay, so when there is no voltage applied in the emitter, we are applying only the base voltage. That time there is a high voltage drop between this region. That voltage drop is called V1. Next, now we in the same thing, now we apply some positive voltage here. Here we are applying some positive voltage into the emitter. When are applying a positive voltage, if that positive voltage induce that p-type material release some poles. After applying this positive voltage, this region will generate some poles, generation of some poles. That poles move towards B1. Why? The holes are positive. The holes are positive electron. See here, this is it is a positive, no? See here, this is also positive. Because here positive, this is also positive. Positive signals get reflect each other. Same poles are reflect each other. So that's why this is negative, no? That's why these all holes are attract towards B1. Okay. When this VE value, applied VE value is greater than V1. That time there is a flow of current. So in this region, when there is no voltage applied in the emitter terminal, in this stage, UJT in reverse bias condition. UJT in reverse bias condition. Without no input voltage. When emitter is connected with the ground, that time UJT in reverse bias, there is no current flow because it is in the off stage. Next, after applying a positive voltage, that positive voltage V is greater than V1. Actually, already because of the application of VBB, there is a drop here V1. So, when VE greater than V1, we are gradually increasing the VE value. When VE greater than V1, that time it is moved to the PN junction becomes the forward bias. When VE, if you are applying, while are applying VE, if VE is less than V1, that time also it is a reverse bias. The junction is in a reverse bias. So if you are gradually increasing the VE value, that time, so this PN junction, the PN junction is in a forward bias. So there is a increase in a current flow here because of the movement of the holes. We already know what is current. A movement of electrons or holes is create a current. Here, due to the movement of holes, there is a flow of current. That current is called IE, emitter current. So now we will see the characteristics, how the characteristics looks like. So see here, we draw the graph between emitter voltage and emitter current. Okay, we are applying emitter voltage. There is a flow of emitter current. See here, initially we are gradually increasing the VE value. This y-axis belongs to VE value. We gradually increasing the VE value. Okay, and what one particular point, after one particular point, with the decrease in the VE value, IE value is increased. See, the x-axis is IE value. This x-axis IE value. So see here, corresponding value. This is called IE value. IE values get increased. So we are gradually increasing the VE value at one particular point. After that point is called VP, that is peak voltage. After that point, that is VE is decreased and IE is increased. See here, actually what is the Ohm's law? V equal to IR. No, if V increases, automatically I is increases. But here, what has happened here? If you are after a particular point, VE value get decreased and IE value is increased. Why? Because here it has a negative resistance value. It means that here resistance value is decreased. So from this point to this point, that region is called negative resistance region. In this region, IE value is increased, but VE value is decreased. See the corresponding value? VE value is decreased. At one particular point V, it is saturated. At one particular point, it is saturated. Even whatever the value, if you are increasing the value of VE value, if you change the VE value, there is no change in the IE value. The IE value is saturated. That region is called the saturation region. Actually, in the cutoff region, the device in the off condition. In the negative resistance region, it is in the on condition. It is here saturated. This is the characteristics of UJT. What is the application of UJT? The UJT is used as a oscillator. What is oscillator? An oscillator used to generate a periodic electronic signal. See how we generate a periodic electronic signal using UJT. See here, this is a UJT relaxation oscillator diagram, circuit diagram. This is a UJT diagram. We connect R and C. This is a R is a path. This resistor is acting as a path to charge capacitor. Charge this capacitor. This R is acting as a path to charge capacitor. So here we won't apply any input signal. Just we are applying a bias, DC bias only. Okay. So initially the capacitor has some charge value. So after application of that is VBB value. So if the VB value is VC value is greater than VBB, that is it is charging. It charge up to particular VBB value. See the diagram, you people will understand. That this is called charging of capacitor. It charge up to VBB value. After reaching the VBB value, it is discharging. So we already know the characteristics of UJT. This is called a non condition, that is it is like a curve. It is generating like this only. So the same way here, charging and discharging of capacitor, that is a flow of the electrical current. IE value is increased and decreased. See here, this is called a charging. This is called a discharging. In the characteristics, this is VP, this is VV. So the repetition of charging and discharging generated this kind of wave. Okay, this is the working of UJT relaxation oscillator. As a summary of the classes, this here UJT. UJT is a 3-terminal device. It has only one PN junction. The N-type bar is lightly doped and P-type material is heavily doped. There is a high resistance between two bases. So working, we divide into two. With the emitter is connected with the ground and emitter with applying some positive voltage. I hope you people understand the working of UJT oscillator and the application of UJT, that is UJT relaxation oscillator. Thank you guys.